Hello, everybody. Welcome to another session of Embrace the Red. Today, we're going to talk about pass the cookie and pivot to the clouds. We're going to talk about cookies, Kekse, Biscotti. And so, what are cookies? We talked about this in a previous session already. So, cookies are used by web applications and web services to authenticate users. This means if you have a cookie, you can access an asset, a web application, a web service. And it's very often it is sort of the single key to the kingdom. So if you have the cookie, you have access to the web application. And this is especially problematic because multi-factor authentication can be bypassed if you steal a cookie. Because the cookie, the final session cookie, is established after multi-factor authentication has been established. So the cookie is often more valuable than the password by itself because it allows a full session impersonation. So a cookie could become or could be the single key to a virtual data center, like an AWS account, a GCP account, an Azure account. Or it could also be the single key to your personal assets. You know, if you think about your bank or your crypto, right? The applications you use, they might only leverage a cookie in the end to authenticate you. If somebody steals that cookie, that is very bad. So be aware of the value of cookies and protect them, monitor them well. Like from a red teaming point of view, it's very important to test for these cases in your organization to make sure that you can detect cookie misuse. So what is pass the cookie? So it is basically a post-exploitation session hijacking technique. This means when we speak about post-exploitation, what we mean is that an adversary has already compromised the computer and has basically administrative access to a computer, and after that, they steal the cookie, and then they leverage that cookie after they have stolen it. So it's a privileged thing, privileged technique where an administrator, an adversary has already compromised the computer. Then they use that, the adversary then uses that cookie from a browser or from related processes, or it could also be tokens. It doesn't necessarily have to just be a cookie, and they steal that and then they leverage it to authenticate as you to or as the victim to other cloud or to the cloud service. And as we have mentioned earlier, this bypasses multi-factor authentication protocols because the cookie has been issued after multi-factor authentication had been completed. So if you look at the MITRE matrix, we can see pass the cookie is basically covered with stealing web session cookies, as well as using alternate authentication material, web session cookie. And those are the two techniques that you can read up in more detail about this technique. So how does an attacker acquire cookies? What are sort of the tools and techniques to do that? First, the malware might go after the cookie jar files, the database files in your computer, like Chrome, Firefox, right? They store cookies and local session information, local storage. They all store that in a database, in a SQLite database. So an adversary might just try to steal that, and there's like tools like Firefox creds, or you can write your own Python script to connect to the database and try to read it. You might encounter that the cookie values are encrypted, but they usually can be decrypted if you are doing post-exploitation, because the adversary runs code as that user. So in Windows, you could use DPAPI to decrypt it, for instance. The second area is they might target the browser directly. This might happen via a technique called cookie crimes that basically is about launching the browser in a debug modus and then connecting to the debug port, debug endpoint on the machine, and then directly downloading cookies from that debug port. That's a very popular technique for a couple of years. I posted about this as well at one point that it just works on Microsoft Edge, like the latest version that is based on Chrome. So that same technique that works on Chrome also works on Edge with very slight modifications. You can read up more on that. Then we have an attacker might directly go after the process memory, right? He might dump process memory, try to search through various processes in your computer to identify cookies and session tokens. A very powerful tool is procdump that also now exists in Linux, so be aware of that. And the final thing is that this is often underestimated is an adversary might actually look through web server logs. So they might not target the client, they might target the server and go through web server logs or Kibana, Splunk, Elasticsearch and try to find cookies that might be stored long term or even short term. They might install a backdoor, an API gateway, for instance, that kind of sends off all the cookies as when users authenticate to the server. So these are some interesting techniques. There's more, but this is sort of a high level overview of what is possible. So, and then how do we actually pass the cookie in the final stages? So the very first and most probable way, if you want to be very targeted and you only steal one cookie that you're interested in, an adversary can use the developer console and then just set in the console. You can write document.cookie and set the cookie value of the stolen session, for instance. There's also web developer tools in the browsers like Chrome, Edge, and Firefox. You kind of like, I put a screenshot here how this looks usually. You can edit, modify the cookies directly in the browser and override a value and then that way impersonate the session of the stolen credential. So this happens basically on an attacker's machine. This does not necessarily have to happen on the victim's machine. After the cookies are exfiltrated, an attacker could do this anywhere on a different machine. And then there's also the idea to just import, export the cookies via browser extensions and then import them. There's a couple of browser extensions that can be used to import cookies. Okay, so let's look at an example of GCP, Google Cloud Platform. So you might be unauthenticated, then the attacker steals the cookie, and now they pass the cookie, which is they go into the developer console right on their own machine, and then they modify set the cookie values accordingly to console.cloud or google.com, and then they don't have access initially, but then they send the cookie in, they pass the cookie into the browser session, and then they authenticate it to the platform. So very straightforward how this actually works after a cookie has been stolen. And as I mentioned, a cookie is often a single key to a virtual data center. Another example with GitHub, adversary compromises the computer of a user and steals the GitHub user session cookie. Then they can do the same thing, just navigate to github.com on their own computer, go to cookies, modify for the cookie for the github.com domain, the user session token, overwrite that value of the stolen cookie, and then pass the cookie and they are authenticated. What can be done to detect such an attack? The first and most important is catch, or not most important, but the first and very important scenario is catch remote debugging port usage. So whenever there's a browser in your organization launched with remote debugging port enabled, usually the default is port 9222, make sure to fire an alarm and investigate why this is happening. Monitor for applications that perform process dumps across a lot of processes or against browser processes especially. The next point about access anomalies is really critical. When an adversary steals a cookie, it uses that as access anomalies. Right? They come from different location potentially, they come from a different browser, they come from a different device at a different time, so that can be detected. And also look for access anomalies to the cookie storage location, somebody that pokes around the cookie storage files. So that's a good place to actually deploy canaries, for instance, to have a couple of canary files that might trigger detections. It's also worth highlighting that an adversary can just proxy the traffic through the victim's computer directly, right? They don't necessarily have to exfiltrate and then use a different computer to replay or pass the cookie, so to speak. And then there's a lot of features that cloud providers also offer when it comes to anomaly detection. So look into those. And last but not least, is to actually perform red teaming and adversarial emulations to test detection capabilities. So if your organization has done a red team or a purple team where, for instance, a remote debugging port was leveraged, then you should actually entertain such an exercise. When it comes to mitigations, this is also personal advice. What you should do is regularly delete cookies or use like a different computer for sensitive operations for banking and so on, where you don't actually have the ability or the risk of downloading or getting infected with malware as often. This comes down to the third bullet, which is be the only administrator on your own machine. And especially when you use a company's laptop, you should not log into personal assets, for instance, because other people have administrative rights most likely on the computer, and that increases the risk profile of your personal information being compromised. I mentioned this already, browse sensitive and high value sites from isolated machines. Don't use one machine for everything. This is especially true for like AWS accounts, for production instances, and so on, which leads basically directly to separation of duties. That's a very important principle in the security world. And I mentioned cloud provider features already, right? Threat detection, firewalls, and so on. And last but not least on this list for mitigations is also consider requiring further authentication than just passwords or MFA codes. But for sensitive operations, maybe you reprompt for an MFA, the usage of passcodes, or maybe for very critical operations, the client needs to have a client-side certificate that needs to be present so that the attacker has to do multiple things, increasing the chance of getting detected while actually trying to steal and pass the cookie along the way. Yeah, thank you very much. That was basically it. I hope it was useful. Happy hacking. Subscribe to the channel